Hello everyone, my name is Tino and this is the start of a new video series I'll be doing on Organico. Organico is my startup with the goal to help farmers scale their production labor-free utilizing automation. On this episode, I'll be talking about harvesting, some of the challenges to automatically harvesting, what needs to happen in a harvesting mechanism, and as well as an overview of the tests I've done in the past with the past iterations and versions of the harvesting mechanism. So to begin, I want to give you an overview of what growing looks like inside an Organico unit. So to begin, you have a cloth substrate, and within that cloth substrate, you'll drop seeds. Now, once the seeds are in the cloth substrate, the seeds will be met with the wetness from the cloth, and the cloth will be wet from underneath utilizing misters. Now, once the seeds are wet, they can begin to germinate. And once the seeds have germinated, their roots will now be met with the cloth, and they'll start to penetrate the cloth. Once they've penetrated the cloth, they'll be met with those same misters that wet the cloth, but now under a full aeroponic environment. That aeroponics environment will provide the plants with everything they need with a fine mist of nutrients and water. Now, once you have leafy greens growing on this substrate and they've fully matured, how do you harvest them? Well, there's the manual way of going about it, which is you have a pair of scissors or another sharp blade, and you separate the mature plant into two parts: the roots, which are not edible and you want to throw away, and the greens and the stems, which are the edible part, which you want to keep. And so there's a separation that occurs. Well, how do you do that automatically through automation? Well, the way I went about it and the way I'll be going about it is through the use of linear rails. Now, this is what a linear rail looks like here, and it's a very simple machine. You have a pillow block going from one end to the other, and that achieves a linear actuation, a linear motion. And with this linear motion, you can do a variety of things. And so why not just attach a blade to one end and see that linear actuation actuate the cutting of those mature plants? Well, that's what I did. And with the first version, as you can see here, I had simply a blade, and I had that blade going through and cutting those mature plants, or hopefully cutting those mature plants. But now you're left with just a bunch of cuttings on top of that cloth. Those cuttings need to go somewhere. Those cuttings need to be packaged. Those cuttings need to be shipped. That is the end product. And that space that those cuttings are taking up, that's the space for the next seeding and the next set of plants to grow. So you need to get rid of those cuttings from the cloth. Well, how do you do that? Well, you need to push them out of the way. So in that first test, I had very simply two different parts. I had the cutter, the blade, and then I had a pusher, which in this case is just a 3D printed red wall, as you can see here. And I had those going from one end to the other. And the pushing element here preceded the blade, so you would get the cut, and then you would get the push. And that was the first test. And here's how that went. Now, as you can see, when the blade was passing through the stems of the plants, instead of cutting them, the stems just kind of slipped through and bent and didn't really meet with the blade properly. So what's happening here? I searched around the internet. I searched through many different ways, people in other industries and different mechanisms of cutting things like grass or shaving a beard, things like that. Different designs that people have come up with for cutting sort of blades of something that needs to stay upright. Well, all those mechanisms that I looked at, lawnmowers and shavers, they all had a mechanism for keeping the blades of whatever they were cutting upright. How did they do that? Well, in the case of the lawnmower, in the case of the barber, you had a mechanism creating an influx of negative air pressure so as to suck the blades, up and to keep them up, so that they wouldn't bend when you try to have a blade meet with them. So that was my idea, and I was going to try to have some sort of negative air pressure along with the blade and with the pusher to create an ideal harvesting. And so with version 2, I attempted to have that. And with version 2, I had simply a computer fan in the middle, creating that vacuum, that negative air, and I distributed that air from just one central point in the fan to the outer edges, as you can see with a shroud right here on the fan. And now here's how that went. And as you can see, those plants are not very mature. And that's because I was kind of losing hope in that this specific version would work, because I was trying to get enough air pressure, but I was trying to get it from one spot, and I was trying to distribute it to every edge. And so with this test, I thought, this is a good try, but there obviously needs to be changes to make. There needs to be changes to this version. So I was going to need more air pressure. So with version 3, I went all out. Instead of having just one computer fan, I have 5 now. And instead of having that shroud design that limits the air, or doesn't limit the air, but that tries to squeeze the amount of air pressure from one spot to the edges, this one instead just stays. There is no shroud element. There's no taking that air and routing it somewhere else. And that was the concern I had, is that by the time with version 2 that air met with the stems of the plants, it was already a very low pressure of air. So with version 3, I have a lot more pressure, and it's a lot more direct on those stems. And that I think was my initial idea, and version 3 captures that idea a lot better. And so here's a harvest test with version 3 that happened just a few weeks ago. And as you can see, now those are mature plants, and that actually worked. So as you can see, the stems are being kept up, or they're being kept straight, and you're getting a clean cut right from the beginning. And I was extremely happy with that. Of course, that wasn't completely successful, because by about the middle, you can see the rail begins to stall. And now, why was the rail stalling? Well, the power delivery on this rail was only on one side, the left side of the rail, by using only one motor connected to just one side of the rail. And so it wasn't symmetrical. And the rail began to slip, and then it got stuck. And that's why you need symmetrical power delivery to a linear rail. So with the next version, that's what I'll do. I'll add more power so that you have a symmetry of power delivery, and hopefully, fingers crossed, that will result in no stalling in the middle. And with that same system, you'll get a complete harvest from one end to the other. And so, yeah, that's been an overview of the 3 versions that have led up to this. And in the future, I will be doing a version 4, and I look forward to updating you with that, and a lot of other things that I have planned for Concept 1, the first delivery unit, and a lot of great things like that that are in the works that I want to keep making videos about. Hopefully I'll also make a video on some of the past experiments, specifically with seeding and growing and different aspects of the prototype farm. Well, that's been it. Thank you so much for watching, and I'll see you next time.